Okay, let's talk about covariance and correlation. They're very, very similar concepts. The math isn't too hard to figure out, so let's just delve right into it. Covariance is, we have our three states of the economy here: recession, normal, and boom. We're trying to figure out the covariance of stocks and bonds, and so we look for the deviation. The deviation compares the return in each state to the expected return. So the return in a recession versus the expected return for stocks is 17 or 18%. In bonds, it would be plus 10%. And so the product of that, we simply take the weighted average. So we're going to weight the average of the two. We do the product, which is simply multiplication. So 0.18 multiplied by 0.10 would equal, or negative 0.18, would equal negative 0.018. So if it's 0.18% times 1/10%, what is 1/10 of 0.18? Well, you put a 0 in there, you move it over one decimal, and you would get negative 0.018. And then the weight, of course, the weights are 33% each, and so we take the 0.018 divided by 3, and we get 0.006. 6 times 3 is 18, so it's pretty obvious how that works out. We do the same thing for normal, we do the same thing for boom, and then we have a sum. Negative 0.0117 is the sum, and that is our covariance. So it's pretty straightforward. It's a weighted average of the products of the two different classes. So this is even easier to see in a spreadsheet, and that gets us our covariance. That's how closely these stocks and bonds move together. Now clearly they don't move together very well at all. They're negatively correlated. That means when one's going up, the other one's going down to some extent. So they're negatively correlated, which is exactly what we want. Now to do our correlation coefficient, our correlation coefficient is rho. P, or rho, is simply the covariance of A and B, which we already figured out is negative 0.0117, and then we simply divide it by the product of the standard deviations, which we've already calculated as 0.143 and 0.082. That's 14.3% and 8.2% from the previous slides. We multiply those together, and so the product of all that is negative 0.998, negatively correlated. So when one's going up, the other one's going down, and one's going down, the other one's going up, which is exactly what we want for diversification purposes, which is why this is an example. So you can see that this is perfectly negatively correlated, or pretty close to it, and so one's going up, the other one's going down, one's going up, the other one's going down. And so over time, on average, you will return a very calm portfolio, because when one's going up, the other one's going down, so they kind of average each other out. And of course, as long as the line's tilted upward, so they're going down and up in an upward fashion, and they both have expected returns that are positive, then you can expect a very calm portfolio weighted, in this case, 50% bonds and 50% in stocks. Now we have a correlation coefficient. So we could do this for any two portfolio or two sets of numbers, two scenarios, which would be really easy to do with two. What if we have 30 in our portfolio? It would be a little bit different too, right? So let's take this one step further and move on.